I know she said
what we have here
it's
is
alright.
a circuit board from a disposable flash
You gon' make it up
disposable
next
camera,
time.
and it's the mechanism that makes
I
the
know she
flash go
knows
off.
it's not
And we
right.
use this circuit board to make a coil gun.
There ain't
Here's
no
the
use
coil
in
made out of
lying.
magnetic wire hooked to a light switch
Maybe
so that
she
we can
thinks
control
I
when the
know
launch is made.
something.
And I'm going to use this diagram
she
here
thinks it's
to
fine.
explain how all this kind of works
Or maybe
together.
she
So that we can make
knows
the coil
something
launch
I
this
don't.
speedy
I'm so tired.
diagram. I
So
kind of have
tired
color
of
coded to kind of
trying.
explain the
Seems
process.
to me that
We see here a few different
maybe
coils to form a transformer,
it pretty
a
much
battery
always
section here,
means no.
a capacitor,
So
and an
don't
oscillator
tell
transistor,
me
and finally
you
the
might
charge switch.
just let it
When the
go.
charge switch is engaged, it completes the circuit through this capacitor coil,
Oftentimes we're
and as the charge builds up
lazy.
on this first capacitor after
It
the
seems
charge
to
switch is
stand
pressed,
in my
that
way.
then causes the transistor
No one,
oscillator
no,
to
not
collect enough
no one likes to be
energy
let
to make a
down.
complete circuit to have it flow through the primary coil. As that primary coil has a change in the flow in electricity, it changes its magnetic field, which in turn, via Lenz's law, changes the flow in the secondary coil, which it produces an exact opposite to what was produced by the primary coil. And this also amplifies the voltage that was originally placed through the primary coil. This voltage, in turn, reacts on the feedback coil, which then cancels out this energy on the capacitor that was built up, because it is an exact opposite. Once that happens, we can start all over following the red line, charging up this capacitor, turning on the oscillator transistor to complete the circuit for the primary coil, which is in yellow, which via Lenz's law causes a change in the flow on the secondary coil, so it completes it over and over and over until the main capacitor has built up enough charge. In that first process that I explained on the diagram, this is the battery holding area where we put the cell. Once that is in place, we have the charge switch over here on this side. Once that is pressed, we are able to complete the circuit, which all this occurs in this first transformer area. And as that buildup increases, it charges this, which is the main capacitor. This is also the transistor in that section that I explained. And that's it. Okay, so explaining the first part on the diagram, I failed to mention that the reason that we have this kind of repeating itself over and over is because we need to have a break in the flow to change the magnetic field. The only way that we're going to continually build up the process through Lenz's law is to have a change in voltage or in the magnetic field created by the primary coil when it has voltage flowing through it. So that's why we keep canceling out this capacitor here, charging it back up and linking through the transistor, the primary coil. So this happens nearly 5,000 times over the course of 7 to 10 seconds. As that process is happening, I mentioned that it charges the main capacitor, which is over here. This allows this rectifier diode allows the positively charged particles to build up here, and the negatively charged particles to build up here. As soon as there is roughly 300 volts charged up on this main capacitor, this capacitor, in function with the resistor, makes this LED light to light up. This indicates that it has enough charge to make the flash. When we see that light, we can then push the trigger button, or in this case the shutter button, which is located right here. And once that circuit is completed, the energy will travel from the main capacitor through this second transformer, again using a primary and secondary coil, increasing the voltage even more to nearly 1,000 volts, and that will then travel to the flash tube, ionizing the gas, causing the flash once the energy is allowed to transfer through that xenon gas. With that happening, in the coil gun, we just omitted this flash tube, and the energy that would have been put into the flash tube we put into a coil to create a magnetic field to eject the BB. Over here on the circuit, we can see that this LED light has lit up, which means we have enough power for a launch. This capacitor has received all of its power via the first transformer, and now as soon as we push the trigger button, which in this case is the light switch, you'll notice the light will go off because all the charge will be discharged into the coil, like so, and allowing it to charge up again. Over the next 5 to 10 seconds the light will charge back up, and the second transformer is actually here under the battery. As you can see here, this is the second transformer, which is connected to the flash tube over here, which we have connected to our switch and to our coil.
Here we see the voltmeter as the capacitor is being charged. Jumps up kind of quickly to about 150, and then it kind of gradually works its way up to about 300 volts. And next we'll see the graph, some of the reasoning for this. At the beginning, the amplitude is much greater, allowing for a greater transfer of charged particles. And as that shallows out, there is less and less of charged particles that are transferred over to the capacitor.
Okay, based on the experiment ran in class and using this formula here, we can calculate the velocity of the BB leaving the coil, and we do this by using the range that the BB had, which is indicated by R. Mine had the range of about 2 to 2.5 meters. We times that by the constant rate of gravity, which is about 10 meters per second squared, all over the angle of which the BB was launched, the sine of that angle times 2, and we take the square root of that and we get the velocity. In my numbers, we have here the distance launched, which is 2 meters, the constant rate of gravity, which is 10 meters per second squared. I held mine pretty much level. The tape on it maybe lifted it a few degrees, so I put it at 7 degrees times 2. And the sine of that, taking the square root of the entire formula, gives us about 8.8 meters per second. Also using the formula for kinetic energy, which is half the mass times velocity squared, the mass of our BBs were about 0.00033 kilograms, and putting that information into the kinetic energy formula, I got a kinetic energy of 0.0131 joules. Using the information on the capacitor on the flash circuit board, we calculated that the capacity of the capacitor was nearly 0.0396 joules. So we achieved nearly 33% capacity or efficiency through our capacitor and our coil. So that's about all you need to do to launch a BB using a camera flash circuit, and hope you enjoyed the video.
Mina senzilanza nona wamino